Hello and welcome to another R tutorial session with E2 tutorial. Today we would go through how to do some R coding for logistic regression, or typically what we call classification modeling. Just going to put out the data we'll be using over here so that everyone can see it. Okay, so as I stated, we'll go through some classification modeling in R, and this will be done using logistic regression. And basically, this is a type of regression that is focused on when the target variable is either a binary or a multi-class variable. So when I say binary, it's 0 and 1. Multi-class, it has like maybe 0, 1, and 2, right? Or for example, if you want to model something like what type of weather do we have out there today? Is it sunny, rainy, or foggy or cloudy, right? Those are different class. So logistic regression, that's multi-class. So logistic regression would be able to help us predict any one of those classes. So we have a typical problem. This is basically from an education perspective, and you would see how maybe colleges or universities or even high schools could use data analytics, data science to solve some of the problems they have with regards to retention, right? Um, I would just summarize what we have here. And basically, the college's administrator is looking at using certain variables such as the student's GPA, and then if they attend a retention program to decide or to find out if those students would come back in the second year, which is called the sophomore year, um, or not. And that's typically because they're having some issues in the sense that they're not able to retain students past the first year, right? So they've provided us with some data. Could we use that data to help them in their decision making process? All right, so here's the data set, which is given to us in Excel. So you could see it has 100 students, and each of those students have a GPA. Also lets us know if they attended the orientation program or not. So 1 basically means that they attended the orientation program, and 0 means they did not attend. And then return, basically, did they come back in the second year or in the sophomore year, right? Did they come back to school in the second year after finishing up their first year? So 1 means that that student came back, 0 means that the student did not come back, right? So, and some things we could observe is this student has a high GPA, 3.78. They attended the orientation program, they came back, right? This student has a fairly low GPA, right? 2.38. They did not attend the orientation program, but they came back in the second year, right? So, and then student number 3 has a very, very low GPA, 1.3. Did not attend the orientation program, did not come back in the sophomore year, right? So that's basically some of the things you could see when you try to just understand the data, right? And then we could kind of just manually check if we have any missing values, any errors or whatsoever. But so far I can see that we have complete 100 variables. There's nothing missing or whatsoever, right? There's no spelling errors or anything that we need to correct up here. Everything is spelled correctly. So this data, I've put it on my GitHub page. So it's called the Lakeland College data, right? So you could just download it from the GitHub page, I would put the link to this page or to this data set in the YouTube description below. So please take a look at it. Okay, so now that we've looked at the data, we know where you can download the data. Let's go ahead and see some of the questions we have to address. Okay, so the first question we have to basically address is to develop the logistic regression model, right? And I would walk you all through this in a bit, right? And then our second question is to assess the significance of the independent variables. So let's go ahead to work on these two questions first, right? And then we'll come back and look at all the other questions that we also have to work on as well. So please open up your R programming software and basically just follow along as we do the coding. So I'm just going to say this is question 1, 2. Okay. So for my first step, or let's just say step 1, right? We want to load the libraries that we require to do our analysis. So the first library would be read Excel. That allows us to just going to be putting my comment in there, allows us to import Excel files, right? The next library would be the HMIM, the higher miscellaneous library, right? And you could see that read out there of what the library helps us to do. But most importantly, what we will be using this library for is to help us with analyzing the correlation between two different variables, which is the independent and dependent variables. And then another library we would work with is the PSCL, right? This is a political science or computational library, right? And basically what this library helps us to do is to call certain metrics that would enable us to evaluate our logistic regression model. So when you're doing linear or multiple regression model, we tend to use metrics like the R-square, right, or the adjusted R-square, but those metrics cannot be used when doing logistic regression. So we use what we call a pseudo R-square, right, which kind of mimics an R-square in order to check the goodness of fit for our logistic regression model. So the PSCL library has that pseudo R-square embedded in it. Now, the next one, we just have to install a library. So first off, if you've not installed any of these libraries before on your computer, I'm just going to go one step backwards, and I would just say step 0 would be to install the required libraries, right? So we'll use install packages, and then all you just need to do is read Excel. right? Sorry, I spelled this wrongly. It's supposed to be install packages. Yeah. So you could just put it there, root Excel, or you could do HMISC, right? Or install packages, PSCL, right? You could install all of those packages. One more package we do need to install is, I actually do need to install it on my computer, although I've probably installed it before, is this one. Let's see. Right. So, but if you don't have any of these packages, you do need to install them. So if you have them, you don't have to reinstall them. You could just comment them out using the pound sign, right? So I have the first three packages, so I don't have to install them. I just need to import them into my R, right? But for number 9, we just run and have that installed, right? So that's basically it here. So let's see. So once I've done that, once I've installed it, I'm just going to comment it out because you don't need to install it over and over again. You just need to install it once, right? So here I'm going to call the library here. Yeah, so you could see there's the very first one, right? So it basically helps us to create an area under the curve graph that shows us how well our logistic regression model is able to predict a certain class over the other class. So in our case, we wanted to predict the students that are going to come back over the students that are not going to come back, right? So that's basically what the AUC does, and it also gives us the AUC value itself, so which is another metric for evaluating our logistic regression model. So please remember, AUC means area under the curve, right? That's basically what it means. So I can just put it here. So everybody knows what it means. Okay, so now we have that. Don't forget to run all of those packages. I'm just going to run them. Okay, so I have all my packages all taken care of. Now I can go to step 2. So step 2 will be to import the data. So I think I could just call it college underscore df. That's df means data frame. Read underscore Excel, and then file, so choose, right? So I can import my data there. All right, so we have that there. Yes. Yep, so now you could see we have our data set in there. So if I click on it, you could see our data set, 100 variables, everything looks nice, nothing is missing, right? But when we look at it and we go back to the question, right, we know that we're given 3 variables to focus on, which is the GPA, and that's our dependent variable, program and return are our independent variable. So we do need to drop this student column because it doesn't help us at all in our analysis, right? So we have to write a code that drops this column or removes this column. So let's go here. So that would be step 3. So as part of your data cleaning or data pre-processing, you want to remove irrelevant um, uh, columns, right? But hold on. But before we remove that irrelevant column, let's, you know what? Let's remove the irrelevant column, then we can summarize our data. So we could say we're just going to rename the data when we remove that irrelevant column. So we're just saying now we're looking at a subset of the data, right? And remove that column called student. That's basically what it's going to do for us. So it's going to create a new data set for us. Our original data set had 100 observations, 4 variables. That basically means 100 rows, 4 columns. Now we've dropped one of the columns, so we have 100 rows, 3 columns. So that's basically how it would look like now, right? So we don't have student. So the first data set, we have student, but now we don't have student anymore, right? So now that we've done that, we can go to step 4, which is to summarize the data. So we can just say, okay, so here we just do show a little screenshot of data and then a summary of the data. So we could see on average, the students have a GPA of 2.7, or we could use the median of, yeah, it's still 2.7, pretty close, right? And then the maximum GPA is a 4. That's amazing. And the minimum GPA is a 1.2, right? And we could also see on average, very close to 1 attended the orientation program, right? And then also very close to 1 kind of came back on average. So that's pretty good to see. Okay, so let's continue. So step 5 would be a feature selection. So basically what we mean by feature selection is to just do a correlation analysis and see which of the variables are important or not. So we're using as matrix because we want it to kind of show us a correlation in a matrix format, right? So basically all our dependent and independent variables, it will show us the R value, which is the determination of correlation, and then yeah, and then it would also show us the p-value, which would let us know if those variables are significant or not. So okay, so basically here's our correlation values up here, and then the second result is our p-value, and just basically represents our sample size, which is 100, right? So here we could basically see that there's kind of like an average or medium correlation between GPA and program and return, right? And then also there's no multicollinearity between program and return, right? So it's not greater than 0.7, which is our multicollinearity threshold. Let me see if I could just zoom this in a little bit. Okay. All right. So, and then also we could basically see that the entire variables are all significant when you look at it from just from correlation perspective, right? So let's continue. So step 6 is to build the model, knowing that we could use all of the variables, right? So if you discover that certain variables are highly correlated, right, or it's not significant, basically in step 6, when you're building your logistic regression model, you will not include those variables in your analysis. So you basically just avoid them completely. So we're using the GLM function because that's basically what we use to build our logistic regression model, right? When we're doing a linear, we'd use just the LM function, right? So that's the difference between the logistic and linear regression. So remember, return is our dependent variable, GPA and program, those are our independent variables. I hope I said that correctly when I was introducing the data set earlier on. So, but if I did not, please forgive me. Just take note that return is our independent variable, sorry, dependent variable. Okay, so this is fun. We've developed the logistic regression model, and then we're going to look at the summary output of the model. So let's run that. And this is basically how a model would basically look like, right? So the reason you put it as family binomial is because you're doing the return variable is basically 1 or 0, right? So binomial represents that. And then we're calling our data here and all the variables we're dealing with. So now looking at this from our output, we can basically see that GPA and program are significant variables, right? Based off the p-value here, right? You can see they're both significant variables. They're all less than an alpha value of 0.005, right? So that means they significantly affect returns, right? And then you could see our coefficients, right? So this is going to be B0, this would be B1, and then this would be B2, right? So there's a negative impact of the intercept on the logistic regression model, right? But GPA and program do have a positive impact on the logistic regression model. So that's very good to see, right? So this basically answers our very first question, which is to develop the logistic regression model and then assess the significance of the independent variable using alpha as 0.005, sorry, 0.05. So we've taken care of those two questions. So let's proceed to our third question now, which is for us to test the overall model significance, right? Is our logistic regression model good or not, right? So in order for us to do this, so let me, before I start saying anything, let me write that question down. So that is question 3, overall model significance, right? So we could check the model significance using different ways or parameters, right? So I'm going to show you guys how to use 3 different ways to check for the model significance. The first one is called the likelihood ratio test, right? And what it basically checks is how well the predictors are actually able to predict the likelihood of students returning to the college or not, right? And then the second one is the pseudo R-square, which I kind of mentioned earlier on when we're talking about the packages, right? It helps to assess if our model is a good fit to the data, right? And then the third one is the area under the curve that basically represents the ability of the model to properly classify if a student will be coming back or not. So we're going to go through all three of these different metrics so that you could see how we use them to assess the overall model's significance. So let's start with the first one, which I'm excited about, the likelihood test. All right, so we're just going to say a null model is and then so here would focus on all the return start of 1, and then sorry, we'll focus on the return and would say we only have 1 as an independent variable, just to see how the model would behave. So this, and then to perform that likelihood test, would use an ANOVA model, which we've covered in a previous video, right? And we've also covered the chi-square test as well in a previous video, but this is basically what we're going to use to, to do this first approach, which is the likelihood ratio test. So we'll run this, boom. So here we can see the result of our analysis, right? So we kind of developed two different models here, right? The first one is just saying we have only one independent variable or using 1 to represent an independent variable. And then the second one is our normal model that we developed already, right? And we want to see what is the likelihood that the student would return and use that to test the overall model significance, right? So looking at the ANOVA result that it has given us here, you can basically see that our model is significant when you compare it on a 0.005, right? So this value here this is just literally 0, right? Basically what that means, if I write it out, is 0 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 4, right? You can see this is so small, so small, right? So that is definitely less than 0 0.05. So our model is actually significant. The overall model is actually significant based on the likelihood ratio test, right? So from an interpretation perspective, so I'm just going to put an interpretation. I would say All right, so that's basically the interpretation for the results that we've done here, right? Basically, what we're saying is that our model, which has the GPA and the program as predictors, is able to perform very well compared to a model that's model one, which only has the mean of the observed outcomes, right? And when we say observed outcomes, if you come to return, for example, we're just saying like if you take the mean, if you make this one, right? So please take note of that. Let's see. So the next one we're going to test out is called the pseudo R-square. So basically, this is just kind of mimicking like the adjusted R-square, because in this sense, we have two variables. So we would want to use the adjusted R-square if we were doing a linear regression, right? But this is a logistic regression. So the pseudo R-square is used. So here's the function, and then the model. If we run this, we get a pseudo R-square, but typically we use the McFadden R-square because it helps to explain the goodness of fit for our model to the data. And there you could see we have a 0.37, which we could say 37.33% or 37.3%. And it kind of captures the variability in the outcome relative to a model with no predictors, right? And would say at least this is a good measure of how well our model is able to fit the data, right? And for the McFadden R-square, we typically say that if you have a value between 0.2 to 0.4, then your model is useful. So in this case, you could see that our value is between that range of 0.2 to 0.4. So we can clearly state that our model is useful. So I'll just put all of that in the interpretation. All right, so that is the interpretation there. The next one would be the area under the curve, which is the AUC, and I explain what we used that for previously. So we're just going to go ahead to compute the ROC curve and the AUC score, right? So we would use the function ROC, and we would have our data there. Remember, we're focusing on the dependent variable, which is return, and then our fitted model. So we're going to create a plot, and then we'd find the AUC score. So let's run this. boom. So here you can see the ROC curve here, and our AUC score is 0.88, right? Which basically means that a logistic regression model has a high level of accuracy in predicting student retention, right? So that's basically what that means. So, and then you always want an AUC score that is closer to 1, right? Which means a very high accuracy. Okay, so before we continue, I just remembered something. Should have put an interpretation here, which is predictors. Yep. And then for this one, some reason I just forgot about it. We could say the average GPA is 2.7. Or let's say the median GPA is 2.7 with the median of with median of 1, meaning students attended the orientation and would likely come on here. Okay, so that's basically how I just interpret that. Okay, so now we can go back, right? So we've done the 3 different methods to check for significance: the likelihood ratio, the pseudo R square, and then the area under the curve. So we've basically answered question number 3, right? Now we get to work on question number 4 and 5. If we're given some new values, right, could we use that to predict if the student will return or not, right? So basically, if you have a student with a GPA of 2.5, they did not attend the orientation, and then you have a student of another student with like still the same 2.5 GPA, but they attended, right? Could we use that to see if they would come back in their sophomore year? All we're just trying to do is, can we use this model to make some sort of data-driven decisions at the college? So this would be, let's say, question 4 and 5. I'll call it predicting new. Let's see, predicting with new information. Okay, so let's say new data. So I would say new data. let's just call it new data 1. Create a data frame and basically say GPA 2.5 and then program as 0, right? Then new data 2 data frame GPA 2.5 program 1. Basically, they attended the orientation, right? So data 1 did not attend orientation, and then this one attended orientation, just to kind of differentiate the two of them. And then we're being asked to do a prediction as well as get the estimated probability. Okay, so the first one let's just predict the probability. So most of the time, what logistic regression does for us is to give us a probability, right? Predict that probability that the student did not attend the orientation and then the student attended the orientation. So I'm just going to say probability 1, which would be for did not attend. So predict model. Oh, sorry, I did not see what I was typing correctly. So model our new data, which is new data 1, and then the type is basically going to be a response. Right, we could say, hold on. So this is, I'll just put it here. That's basically what that probability is, that the student did not attend the orientation. Okay, so if we run this, oh, my bad, I did not run line number 70 and 71. Okay, all right. So you could see that probability is 36%, right? So 36% that the student may not return. I could just multiply this by 100, right? So you could see there 36% that the student will not return. So 36.7% that the student will not return, right? So what I'm going to do is I would copy this so I don't have to type it again. And then I'm going to call it probability 2. This would change to 2. And let's see what the probability for this one would be. Ooh, 73%. So can you see how high it is when the student actually attends the orientation compared to when they do not attend the orientation? So here it is 73.4% that the student will return, right? So that's basically how we answer question 4 and 5, right? In terms of showing the estimated probabilities that a student would actually return based on their GPA and the fact that they attended the orientation program. So the last question here is, what is the estimated odd ratio for the orientation program? So that's the last thing we have to do, which is our final question. So let's look at it. Okay, so first off, we have to extract the coefficient, which we already found when we were working on question 1, right? So I would just say coefficients. You get that from doing the summary bracket model. So the coefficients are basically our B0, B1, B2, right? That's basically what they are. And then we could use that to calculate the odd ratio. So this would be based off the orientation program. So our odds ratio is going to be based off the orientation program, right? So odds ratio. So we're just taking the exponents of the coefficients. Coefficients. This, yeah. So I'm doing it with the program, which is my independent variable, and then the estimate of my coefficients, right? Basically this, right? I'm doing it with this, just this first column here, right? That's what I'm doing, calculating the odds ratio with. Then I'm just going to, so let's show the result there. So let's run this. So my odds ratio is 4.76, right? Which is greater than 1, right? And that indicates that attending the orientation program is associated with higher odds, right, of students returning for sophomore year compared to when you do not attend the orientation program at Lakeland College, right? So anytime you have that odds ratio greater than 1, what it just means is that one variable has more impact. Sorry, what you've classified as 1, or depend on how you do the classification, right? What you've classified as 1 in your data. So in this case, 1 means that students will come back, right? And then 1 also means that students attended the program, right? So here, if they attended the orientation program, then there's a high chance that they would come back in their sophomore year. Okay, so as an interpretation, all right, so this is basically all what I have for you today. I hope this is helpful. Do not forget to save your R code, right? And please like this video and also subscribe to our channel so that we can bring you more awesome content like this. Thank you so much for watching. Bye.